Hello. In this lesson, we're going to talk about function. Function is this one single most important concept in this course. And in the past, I'm sure you have learned function before from your algebra classes. So I'm going to take this whole time to explain to you before we are introduced to trigonometric functions. Right? If you look at the title of the textbook, it's called trigonometry. If you go through the chapters, oftentimes you hear, the words trigonometric functions they mention here and there, everywhere. And we want to understand what is a function to begin with, okay? A function is a rule, okay? It's a rule, but this rule has to comply with certain conditions, right? So that is a description of this rule, what this rule must be. So this rule assigns to each element x in a set of A, okay? So there's a set of A, and the rule applies to one element from the set, one at a time. Each time it applies the rule to one element in the set, it produces, right, exactly one element called f of x in the set of B. So we see there's a set of A where the rule applies to each element in that set. And after the application of the rule, it produces for each element, okay, we call it input. It produces exactly one output. So this word is essential. Exactly one. It cannot be more than one. It cannot be less than one either. It has to be exactly one. So sometimes we also use the word unique, right? So this f of x has to be unique. So for each x, the rule applies to x. It produces an output. This output for this particular input has to be unique. Now, a natural question would be, if we have this rule, how many inputs that this rule could apply to? So we will be interested in all of the inputs, right? All of the inputs such that the rule could apply. Okay? And for each application, it produces exactly one output. Okay? For each application, it produces exactly one output. We will be interested in all of the inputs such that the rule could apply. And all of these inputs together makes domain. Okay, so domain is addressing that all of the inputs such that the rule can apply, and for each application, it produces exactly one output. Exactly one output, right? So it's natural for us to ask such a question. Now the next question comes. The next question says, well, you have all of these inputs, to which you can apply the rule. And for each input, it produces exactly one output. So how about I put all of these possible outputs together? All of the outputs together makes the range. Okay, so the range is a collection, all possible outputs, okay, produced by applying the rule to each input in the domain. Okay, so you can say that the range is a consequential. The range is a consequence of the domain. Okay, so let's look at some examples. Before we look at some examples, and we want to have a little modification about the definition of function, okay? So now you can see we are concerned about the rule, and we're also concerned about domain and range, right? So now we can say a function is a rule that assigned to each element, okay? We can say each input in a set of A, how about we call it domain? Exactly one output. Okay, we call it f of x. And where would it be? In the range. In the range. Right, so now definition of function is written like that. In short, right, we draw this diagram. Every input from the domain, right? And it produces exactly one in the range. And sometimes we use shorthand notation for domain, which is D, and we use shorthand notation for range. Okay, so please write this down. This is the single one important concept in this course, in this entire course and beyond. Okay, and beyond these courses, right? Pre-cal, cal, you're gonna see this concept mentioned over and over again, and you're gonna see that how these functions are being studied. Some of them are explicit, implicit, but they all use the word function. So we're going to study, and for most of you, I believe this is probably review. Okay, the first function. Okay, suppose it's a constant function. Okay, pay attention that I'm also using some specific notation. You may or may not be familiar. Okay, so please take notes. And if necessary, pause the lecture and listen to it all over again. So first of all, the constant function. Okay, so before I did some preparation before this recording. So when you look at this function, right, function is called a constant function. What is a constant function, right? We're going to explain this. The constant means stay the same, doesn't change. Same number all the time, the same output in this particular situation for any input. That's what it means. The same output for any input. That's what it means. Now, if you have chosen a specific output, say you have chosen specific, let's say in this case, we're going to choose number 2. Okay, once chosen, it's set. So this rule of the function says, whatever input you give me, I'm going to assign that input exactly the same output, which is 2. That's what it means. Okay, that's how you see this picture. That's how you see this picture. Okay, right here. Any number you assign, you give me as input. The assignment, this rule applies to the input given is going to produce 2. So f of x is equals to 2, no matter what is the input. So now the question is, what will be the domain? And what will be the range, right? What will be the domain and what will be the range? That's right. The domain will be all real numbers. All real numbers. And the range, what is the range? No matter what is the input, the range, the output is always 2. The output is always 2. So the range, in the range, there's only one number. There's only one number. And then that one number is 2. There. Okay, so domain range is completely determined by the rule itself. Completely determined by the rule itself. So let's look at the graph. Okay, as the rule dictated, right? No matter what input you give me 0, the output is going to be 2. You give me -3, the output is going to be 2. The input is 5, the output is 2. Okay. And if I put input, comma, output together as an ordered pair, right? And I got points. And also pay attention to this notation. Okay, we're going to be using this notation a lot. Okay, and you will continue to use this notation in your future classes, like pre-calc, calculus classes. You have multiple calculus classes and beyond, right? So get used to this notation. This notation is neat, right? It tells you the input is 0, the output is f of 0. You read it as f of 0. F of 0 is 2. It tells you the input is 0, the output is 2. Okay? So now, ordered pair, output. So this notation tells you the input is 0. The output is f of 0. Okay? So in this notation, you could also write these notations, right? You're going to see this a lot. So input is 0. The output is f of 0. Then you say, what is f of 0? Well, I don't know yet, right? Until you find it, you can have a placeholder. You can have a placeholder to hold up space for your output. And on this one, you can also use this notation that input is -3 and the output is f of -3. No problem. You have a placeholder. Then you say, what is the exact value of it? Well, I don't know. If I know, I'll replace it. If I don't, I have a placeholder for it. Okay. So for input 5, same thing. The input is 5. The output is f of 5. Okay. So new notation, right? We address this very important concept. Okay. So we already have the domain and range. Okay. And we're going to plot the points. We're going to plot the points. Okay. So when we plot these points, what do we get? This is what we got. Okay. So let's mark these points. Let's mark these points. This point, obviously, is -3, 2. Okay, the next point over here is 0, 2. And the next one is 5, 2. And this graph, as you're all very familiar with, right? How do we read that graph? For example, for -3, 2, right? -3, we measure, the input is a horizontal measurement. It's a horizontal measurement. Okay. That's -3. To the left of 0, we measure 3 units horizontally. And what is 2? That height is 2. Input, output, the number, and the geometric measurement. Now, how about 5 sub 2, 5, 2? 5 is a positive number, so you measure 5 units from 0. There. And what's the output? The output is 2. So when you see the mark of the point, you know how they're measured. You can also see the geometric, okay, the geometric meaning of it. And apparently the both red are above x-axis, they are actually positive. So the output are positive, right? You can see if it's a positive output is over the x-axis, is negative output is below the x-axis, okay? So that's the picture, okay? So we have studied this rule. Let's study another rule. Let's study another rule, okay? So I'm gonna clean this up. Let's go ahead and study another rule. Okay, that's a little summary, right? And once again, let's continue this study. Okay, so this time we're going to use the, I still bring the definition of function right here, right? You can use we can use the tweeted version of it, right? So let's bring that tweeted version of function. The new version of it. Okay, there we go. The second function. Okay, this function is also very, very important. Okay, this function is also very important. What is the rule of this function? What is the rule of this function? Okay, the rule in this function basically says, okay, so let me put it up here. Okay, for each input you give me, okay, I'm not going to make any change. The output is going to be the same as the input. That's what this rule says. No, you give me an input, sorry, you give me an input, I'm going to use that input as output. So output is always the same as input. That's what this says. Okay, so if the input can be any real numbers, right? So what will be the domain here? Of course, all real numbers, I can hear you, right? So what will be the range? What will be the range? Well, the input and output are always the same. So if all real numbers are in the domain, of course, it's all real numbers in the range, right? That's why domain and range are the same. Okay, so now with this rule, remember this rule, right? Output is always the same as the input. So whatever input you give me, I'm gonna just use it as the output. Okay, so let's plot some points. Let's plot some points. Input a -1, output a -1. Input 0, output 0. Input 2, output 2. Input 2.5, output 2.5. Input 2/3, output 2/3, because the input is always the same as output. Okay, and then we plotted these points. We plotted these points. We plotted these points, right? So let's mark a couple. Let's mark a couple, right? So we have this point here, right? That's 2, 2. 2, 2. And over here, that's input -1, output -1. Right? You can mark all the points. And what do we get? We get a straight line. We get a straight line. So this is the line we call y equals to x. Y equals to x. Okay? So make sure you take notes. Make sure you understand it's a rule. Okay? This rule determines domain and range and the graph. Once a rule is set, it determines the domain, the range, and the graph. Okay, it's always determined. From the graph, you can tell, right? And this piece is above x-axis, that's positive, right? That piece is a positive. And that piece is a negative. And what happened at a 0, 0? That's a turning point. That's a turning point. So that point is a turning point, right? 0, 0. output from negative become positive. And what and more, you can see the graph is going up, right? So when input is getting large, hold on, let me use a different color, okay? When the input is getting larger and larger, okay, when the input is getting larger and larger, what happened to the output? The output is getting higher and higher, right? You see that? That's actually called increasing. Okay, we're going to talk about that property in the future. There. Okay. All right, so let's look at another function. Let's look at another function. So we're gonna take the definition of function along with us. Okay, we're gonna take the definition of function with us. Okay, because we really, really want to see how this definition applies to the examples. Okay, so we got this function covered. Okay, next one, x squared. Okay, our function definition with us. Okay, our function definition with us. And what is this rule? This rule is f of x equals to x squared. Any input you give me, I'm going to take that input and multiply itself. So because x squared means x times x. So whatever input you give me, okay, according to this rule, I'll take the input and multiply itself. And obviously the domain is all real numbers, right? You can do that with all real numbers. How about the range? Well, if you take any number, multiply itself, I mean real numbers, right? It's never going to be less than 0. So it's all non-negative numbers, all non-negative numbers. We have the interval notation, we have the, the algebraic notation, right? Domain range in one sentence, right? I believe this function is pretty familiar to all of us, right? If you have any questions, please don't hesitate to ask me. Excuse me. So, so domain and range in one sentence, domain range in one sentence, right? This is domain range in one sentence, and this is domain range in one sentence as well, right? So very, very, very important. Plotting points, okay? Plotting the points, I just plot input and -2, the output is -2 times -2, that's a 4. Input 0, we get 0, output, input 3, we get output 9. So we get all of these points here. You can make a table, a lot of textbooks that make a table. And we plot the points and can make the connection. We connect the dots. Okay, mark these points over here. -2 input, output is 4. Input 0, output 0, input 3, output 9. So once again, we want to see that the meaning, right? The geometric meaning of it. Okay. So when the input is a -2, so here's -2, measured 2 units to the left. Okay, so let me use different color. I'm kind of reserving the red color for the output. Okay, so this is the input of -2. Okay, input of -2. Hold on, did I make it too long? I did, right? I wanted too long, just right. Measure 2 units to the left because it's -2. And the output is +4, measured from 0, right? 4 units. Consistent, you can see the geometric meaning doesn't change. Okay, and input is 3. right? Output is 9. Measure from 0, from this level 0, all the way to number 9. Okay, so 3, 9, you can see that's a 3 and that's a 9. Okay, but this piece is interesting. It goes down, 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 down on one side. Okay, when the input is getting larger and larger, when the input is negative, the output is getting shorter and shorter. Okay, the output is getting shorter and shorter, right? They're getting shorter. On the other side, however, as the input is getting larger and larger, the output is getting what? Larger and larger. Okay, so on this piece, you say it's decreasing and the other piece is increasing. Okay, but that's just some observations, right? That's just some observations. So we covered one more function. Of course, we have more functions to cover, right? We get some interesting functions, and some of these functions we'll get to use them in the future for sure. Okay, so let's look at another function, x raised to the power 3. Okay, and the rule is clear. The rule is clear. For each input, okay, we take that input, we multiply itself 3 times to make x raised to the power 3. So input and output, right? So if you say, hey, input output is like input is x, right? And output is x raised to the power 3. You can write it that way. Hey, why not? Right? That's essentially what it is. Okay. Yeah. Input output, right? So that's the input output. Okay, so input output. In this particular situation, input output, right? That shows the relationship between the functions, and you can see the rule. This is the rule, and we plot points. Domain, all real numbers. Okay, you can take any real number and multiply itself 3 times. And what's the consequence? This function should not be very unfamiliar with us. You probably have done that before. So I'm going a little quick. Okay, so with this rule, domain all real numbers, range all real numbers, and you plot some, you have some negative number input and then a positive number input, just choose some random input output and you get some points, right? And we connect these, we plot these points and connect them, and we get the next picture. We get the next picture. Okay, if you look at these pictures, right? I'm gonna mark a couple of them. So this point is -2, -8, right? When input is -2, the output is -8. And this point over here, when input is 1, the output is 1. And the other one is input is 2, output is 8. It's a very, very important function. You shouldn't be surprised that you take a trig and then you take a pre-cal and then you take calculus class, you find yourself using x raised to the power 3 in chapter 3 or chapter 4. I think it's chapter 4. Okay, you still be using this function, and this function has a vital role to play to illustrate some theories that you're about to learn in that class. Okay, but anyway, so make sure you're familiar with this function. Domain is all real numbers and range is all real numbers as well. So I'm just making a little adjustment for that picture. Okay, really it's not essential, but that's the curve. That's the curve. So this way you see better, right? You see better. Anyway, so that we got that function. Okay, so let's look at another function. This function is also extremely interesting. It's called reciprocal function. reciprocal. And what is the rule? This function is a rule. What a rule is it? It's assigned to each element in the set of A, exactly one element, right? You give me an input, I'm going to take it and produce a reciprocal, produces a reciprocal. Obviously, we cannot take 0 as input, right? If 0 is the input, it's going to have a 0 as denominator, and 0 cannot be denominator. Excuse me. So domain, okay? Domain is easy to determine. Range is a little bit more difficult, but I'm giving you some examples, okay? I'm gonna give you some examples and I'm gonna make a table. Okay, so you're gonna see some cases. You're gonna see some cases, okay? Hopefully that will enhance your understanding. So I've chosen these points, which are easy, right? Input, reciprocal of the input, input, reciprocal of the input, right? Input, output, input, output, input, output, input, output, input, output. You can see the output is always the reciprocal of the input and vice versa, okay? And of course, you can also say that this picture, sometimes the ordered pair is called an image, okay? Even though we don't use that word, but it sometimes is called different textbooks. They have different wordings. As you get into more and more mathematics, so you have all these different ways of saying it. Here is a -2, -3, and I'm sorry, this doesn't look very clear. So I'm going to make the fonts just a little bit larger. Okay, so you see that. Ordered pair. Okay. So these are negative numbers. I also give you some fractions, right? Some fractions. And then as you can see, as we get more and more of these, naturally we try to make it shorter, right? So we're gonna have input, output in a table. In this table, okay, I've constructed this table in such a way. And first of all, I introduced first of all, we saw these numbers, okay? If you need to slow down, so maybe pause the video, watch back and forth. First, look at these, right? We did these numbers, that's pretty straightforward. A -½ right? The reciprocal of -½ is a -2, so we have this operation right here. And we cannot have 0, right? We cannot have 0. So then is a +½ okay, +½ okay. So let me remove this piece first. Okay, we know 0 is undefined. Okay. Actually, I'm going to put it over here. Never mind, just it's no big deal. Okay, so I remove these points. Okay, I'm just going to put it back for you guys. Okay, never mind, don't worry about it. So look at these points. These points are fairly easy to calculate, right? From -3, -2, 1, 1/2, nothing for 0 because 0 is undefined, and ½ 1, 2, 3. Okay, so for these we plot these points, right? You can see these points. Look at these points. Okay, so I'm going to bring this down so don't get you guys distracted. All right, so I'm going to mark these points. So we don't get too fast, right? You can see this point right here. This red one is 1, 1, right? 1, 1. And this point, however, here is 3, 1/3, right? And in the middle here is 2, 1/2, and I'm not going to mark it because it will be too crowded. And over here, this point is -1, -1, And this point here is -3, -1/3. Oops, not m, comma, sorry. Okay, now, so these are the points you saw on the table, right? Input is 1, 2, 3, input of -3, -2, -1. How about this point? This point is 1/2, comma, 2. And this point, however, okay, is 1/3, comma, 3. You see, input is 1/3, output is 3. They're just reciprocal to each other. Excuse me. This point, -1/2, -2. They're reciprocal to each other. And this point, this lowest red point, that's -1/3, comma, -3. Okay, so we have plotted all of these points. And what are these points, right? So please take notes. If you need to pause, please pause, because I'm about to erase it. The reason why I have to erase it is because I'm using two software that they don't talk to each other. If I move one and the other one doesn't move. Okay, so make sure you mark it. If you don't, just replay and mark it. I'm going to go back to the table, right? And we just plotted all of these points, all of these points except 0, right? We plotted these points, right? I just marked, and all of these points, Now, why we indicate that it's 0 here, right? It's not defined, right? But what's going on in the neighborhood of 0? What's going on in the neighborhood of 0? Right? Okay. And what's going on in the neighborhood of 0? That's what I just put it away. Okay. So for these two, in the neighborhood of 0, right? The input is 0. We want to observe what's going on, right? What's going on when we are approaching 0, right? What's going on when we are approaching 0 in this direction? Well, we are approaching 0 from this other direction. So I chose a couple of numbers just for you to see, is that from this, in this direction, the number we chose is larger than 0, but approaching 0. And these numbers are approaching 0, but smaller than 0. So they're negative, right? So what are these numbers I have chosen? Okay, so in the larger than 0 part, I have chosen a 0.01 as input and 0.1 as input. Okay, so the output will be calculated right here, because when the input is 0.01, the output is 1 over 0.01, and that quotient is 100. So that point is 0.01 as input, and output is 100. For 0.1 is the output is 10, right? 1 divided by 0.1 is 10. We get another point, which is 0.1, comma 10. So what do we see here for these 2 points, right? You can see 0.1 is close to 0, but 0.01 is even closer to 0. Their output are getting larger and larger. Okay, their output is larger and larger. So that shows us, right, in this picture, okay, in this picture, I'm going to remove this one. I'm going to bring the picture over here. Okay. smaller fonts, right? So look at these two rows. Look at these two rows. Okay, look at these two rows. Maybe I should make the fonts a little bit even smaller. Okay, so look at these two rows, right? 0, so we're approaching 0. We are approaching 0, right? Say, suppose this is 0.1 and 0.01. And the curve, right? The output is 10, 100, getting higher and higher. Getting higher and higher. So this is the reason why I plotted the points this way. Okay, so now I want you to put on your thinking cap. Okay, so we are approaching 0. So before we put on your thinking cap and go further, right, I'm going to write down the mathematical expressions of okay, of this process. Okay, so as the input x approaching 0 from larger than 0, right? I put a little plus sign on the shoulder. The output, right? The output is approaching, you see, from here, right? You can see from this process, right? As it getting closer and closer to 0, the output is getting what? Is getting larger and larger. So that's the red and that's the blue, right? So how do we express that in mathematics? Well, 1 over x will be approaching infinity. Approaching positive infinity, if you wish, right? Infinity and positive infinity are the same thing. Okay, so for the same reason, I want you to observe the other side. So I'm choosing the value of negative 0.01, negative 0.1, right? There's a little negative sign there. Okay, sorry, you see that these two software don't talk to each other. Okay, so what do we observe? Right? When the input is negative 0.1, so we have f of negative 0.1, and the output is 1 over the input, negative 0.1. So that's going to be equals to negative 10. For f of negative 0.01, the output is going to be 1 over negative 0.01. So the output is going to be negative 100. Okay, so in the other side, right, on the other side, we are trying to observe, right? We're trying to observe as x approaching 0 from smaller than 0. Okay, what happens to the output? Okay, so that's our goal. So now what do we have found is that as x is approaching, as the input, okay, is approaching 0 from smaller than 0. Okay. I'm going to insert a row here. There. Okay. As this approaching 0, as the input approaches 0 from smaller than 0. And the output is approaching what? The output is approaching from -10 to -100 is approaching negative infinity. Negative infinity. Okay, so you see the points. Okay, you're going to see the points. The output is going to be from -10 and keep going and approaching negative infinity as we're getting closer and closer. You see that dynamic process is approaching negative infinity. So these 2 points are when the input is -0.1, the output is -10. Hold on. Oh, I should put it here. -0.1, the output is -10. If the input is -0.01, the output is -100. Oops, -100. That shows the phenomena on this side, at this corner, okay, at this corner. And how do we express it mathematically? So when the input is approaching 0 from smaller than 0, so we put a negative sign on the shoulder. Okay, we put a little negative sign on the shoulder. Can you guys see that? Can you see that? There's a little negative sign there. So you may not see it as well. So I'm going to make the font just a little bit larger. Okay, 160%. Let's see if that makes it. There, no, still not. 175%. You know, that will work. Oh. Wait. Right here. X approaching 0 from smaller than 0. Okay, from smaller than 0. Okay. When X is approaching 0 from smaller than 0, which we saw these 2 examples, right? And when X is approaching 0 from smaller than 0, what happens? The reciprocal approaches negative infinity, okay? Which is what we just saw on the picture. So from the numbers, we saw that as the input is approaching 0 from smaller than 0, and the output is approaching negative infinity indefinitely. Okay, so what those are, that's how these numbers, that's what those numbers means, okay? So take the notes right now, and I'm gonna make the fonts a bit larger so you can see it. No, it's gonna be a little bit difficult if you, well, make sure you have these lines here, okay? You have these lines. Then we have two more sides to show you, okay? Which is what happens if the input is approaching, I used the wrong color, okay? What happens if the input is approaching negative infinity? What happens if the input approaches positive infinity? What happens to the output? You can see clearly in both cases, they approach 0, right? But one is approaching 0 from smaller than 0. You can see this piece of curve is smaller than 0, never cross the x-axis. On the other side, right? On the other side, and this piece of curve is always above x-axis. So this is approach on this side, when the input is approaching positive infinity, the output is approaching 0. So what do we show here? On the table. Okay, so what do we show on the table is that when X is approaching, clear all drawings, right? hold on. I think I can make the fonts a little bit smaller to show this piece. Okay. Okay. When over here, yeah, got it. When x is approaching negative infinity, the function approaches 0, but a negative. So from smaller than 0. Do you see that little 0? There's a little negative sign on the shoulder. 165%. The software is very, sometimes it does show with the smaller fonts, but anyway, it shows us the part I want to show. Look at that, right? When x is approaching negative infinity, right? The output, right, is negative, even shorter, right? Even shorter, getting shorter and shorter. Let me not using the arrow, using the line because the arrow is just getting very, very big. You can see that the output is getting shorter and shorter, but in getting shorter and shorter, getting closer and closer to 0, but never touches 0, but it's beneath 0. That's what it means. That's what it means. As x approaching negative infinity, the function value, the output approaching 0, but smaller than 0. So that little negative sign on the shoulder of 0 means less than 0. Okay, it means this whole thing means approaching 0 from smaller than 0 side. Okay, I hope you guys just try to make some effort to understand these notations. You're gonna need this a lot, and I'm gonna just give you some perks about, in the future when you take calculus classes, you're gonna see these notations. You can see how naturally they actually show up. Okay, and we could use it in algebra classes. And the next piece I want to show you, okay, is that I'm gonna take this picture. I'm gonna take the picture here. Okay. Wait. Okay. Okay. I think we can get it. Okay, just this piece, right? We give you all these numbers. The input is 100, 1000. You can see the output is getting smaller and smaller, getting closer to 0, but it's still larger than 0, right? So in this picture, on this side, it basically shows as, these are the 1,000 words, in the picture. Okay, wrong color. I'm gonna show the blue. As x is getting larger and larger, you can see the output, right? The output is getting shorter and shorter yet, right? More than 0, but larger than 0, never touch 0. So it's always approaching 0, but from larger than 0 side. That's what we meant by this notation. Okay, so I made the effort to introduce these to you. If you don't get it, that's okay. It's welcome. You're welcome to ask me any questions about it. If you don't have energy to get this, no problem. You get them in calculus class at that time. You will get it. You have to get it. Okay, but anyway, without further ado, so we have covered these functions. Summarize. So I put the summary on in this table. Okay, I put the summary on this table. I feel this table is so important. Okay, to see the endpoints, right? To see the tails, to see these 4 corners, to see the behavior at these corners. of the curve. That's what you usually do, and you get to observe in calculus classes. Okay, and before you get into calculus class, and we're mainly doing these pieces, doing these pieces, and then you say, hey, this is a trigonometry class. Well, in trig class, we also have observations to the end points, right? So because your next course is going to be pre-calc, you're soon getting into calculus classes for sure. So I feel it's not going to harm you if I introduce these things to you right now. Anyway, without further ado, we have covered this function 1 over x and summarize it, right? Domain and range, right? And one more function, I think. Maybe two more, sorry. I think it may be more, okay? I try to cover all of these functions in one sitting. If you have to take a break, go ahead to take a break, okay, and come back. This function is called square root function, okay? What kind of rule is this? You give me an input, and then we take that input, and then we take square root of it. So the square root of the input is the output, okay? So domain and range is then determined, right? The domain can only be positive number or 0. You cannot say it's a positive number. Because if you say positive number, you have excluded 0. Okay, you have excluded 0, and we have to include 0. So you can say the domain are all non-negative real numbers, okay? X greater than equals 0. The range, as a result of taking square root of all the non-negative numbers, of course, the range is also going to be non-negative numbers. So that's a domain and range, okay? And then you say, how about negative number? Could I take square root of negative number? Yes, you can take square root of negative number, for sure. But you're out of the real number category. And in our graph, a complex number cannot find a place. Okay, that's why we don't deal with negative input in this situation. The square root of -1 is I indeed. I'm glad you know it. But in our situation, we deal with real numbers output only. Okay, we deal with real number input output only, because a complex number doesn't find a place in the rectangular system. Therefore, we say it is undefined. It is undefined. Hope that's clear to you. So we pick some inputs here, and we take square root of them, and we plot them, and we get that curve. We get that curve, right? So if you like, we can mark a couple points here. When input is 1, output is 1. And over here, and this input is 2, output is 4. And I put this point over here, the input is 2.25, the output is 1.5. Okay, so that's the curve for the square root function. Okay, so please take notes. And I'm going to just go move forward because we have other functions to cover. Cubic root function, okay? When you take a cubic root, you don't have complex numbers. Cubic root of -1 is -1, because -1 times itself 3 times is -1, so that's not a problem. So domain and range for cubic root function is also all real numbers. I'm going a little faster here. If you have any questions, please don't hesitate to ask me. I'm introducing these functions for good reasons, okay? Even though this is a trigonometry class. Okay, so for next lesson, we're going to talk about one-to-one function, and you will understand why. And as we go further in trig contents, you will understand why I do what I'm doing right now. Okay, so we plotted some points. And these points I plotted, the input is -8, -1. I choose the easy numbers. the cubic root of -8 is -2. The cubic root of -1 is -1. So this way we got all of these points and we plotted them respectively, right? So see this point is a -8, output a -2. And over here, that's input is 1, output is 1. And on this point, that's 8,2. So that's the curve for the cubic root function, okay, for cubic root function. All right, so these are the functions we have reviewed. You probably have learned this in your beginning algebra class, intermediate algebra class. And whether you're familiar with them or not, and please make the effort to try to get familiar with them. And after that, I'm going to have a summary for you guys, okay, on these functions we talked about, okay. Constant function, x squared, x cubed, 1 over x, right? Square root of x, and wait, what did I do? Okay, cubic root of function. Okay, so domain and range are all summarized. A domain and range all summarized. And for 1 over x, I have this little table here. Okay. You should have enough time to get, you should be able to get them by scrolling down and just play the videos, you know, over to get these messages, right? So we have these summaries for you. I will also create a file and to make it available to you. And so summarize, right? A function. Oh, okay. I think I put it over here. All of these functions. And then one more. What did I do here? Okay. This is what I did. I know what I did. Okay, 1 over x. Okay, so this function is summarized for 1 over x, right? Domain and range, we had it before. And for these functions, I group them in a slightly different order. We cover them, but I shouldn't bother. A constant function, output the same as input, cube function, cubic root function, square function, square root function, and of course this one, domain range here. So these are the functions we have covered. There's 7 of them. There's 7 of them. The absolute value function, however, I will cover in another time. So far, I don't see there's any need for it. So I'm not going to cover it right now. So probably in the future weeks, right? So right now, just review these functions and check out the homework. Okay, the homework part really is exercise your basic skills, such as rationalization and so on and so forth. So let me know if you have any questions, and then I will meet you at office hours, or I can, according to your questions, I can make a recording for you and make it available for everyone. Okay, so thank you for watching. So you can scroll down to see these contents and summaries. And if there's anything more I can do for you, please let me know, and I'll see you next time.